Welcome everyone. We are discussing derivatives. Today I will discuss logarithmic differentiation. So what is the use of logarithmic differentiation? So let us consider a function. Suppose y or fx equals to a to the power x, e to the power 3x, cube root of 2x plus 1 sin x. So, product of four functions. So, up to 2 or 3, we can differentiate it by product rule. But if it is 4, if you take this as 1 and this as 1, then performing derivative it will be how lengthy. So in this case we take log on both sides. So what will be the advantage? So log of product equals to sum of log. So log fx or log y equals to log of a to the power x, e to the power 3x, 2x plus 1 whole to the power 1 by 3 into sin x. Now sum of log, so it can be written as product of log, it can be written as sum of log. So log e to the power 3x, log 2x plus 1 whole to the power 1 by 3 log sin x. I have already stated here log means base is e. In mathematics, whether it is log or ln, we consider base is e, not base 10. So log fx, now you simplify it. So log x log a, 3x log e is 1. Power come forward, log 2x plus 1, and this is log sin x. So this is our first part. So take log on both sides, you can express it as a sum. Now after taking log, you must simplify if possible. So look, log a to the power x log a, 3x log e. Log e, what is log e? Log e is again 1. So we are getting this. So differentiating both sides with respect to x. This is log fx. If we consider this as y, so this is log y. Log y or log fx. So derivative of log y, 1 by y into dy by dx. This to be noted. Derivative of log y, you know this is 1 by y and you are performing derivative with respect to x. That is why you are getting dy by dx. Not only 1 by y. Now x log a is constant. Derivative of x is 1. Derivative of 3x is 3. 3 come forward, derivative of x. So this is 1 by 3. As it is 1 by 2x plus 1 into derivative of 2x plus 1 is 2. And 1 by sin x into cos x. So function of function, log sin x, 1 by sin x, ddx of sin x. So most important part of derivative is derivative by chain rule, derivative of function of function. Now what is dy dx? So dy by dx equals to y into log a plus 3, 2 by 3, 1 by 2x plus 1 plus cos x. This is dy dx. So put value of y. So what is y? A to the power x, e to the power 3x, cube root of 2x plus 1 into sin x. Then this one is unchanged. Log a 3, 2 by 3, 1 by 2x plus 1 into cot x. So this is our final result. So listen again. Y is given as a product of several functions. So if you take log of product equals to sum of the log. So using this concept, we can find derivative of function given in product form. So it is generalization of product rule. So use one. If function is given as a product of several functions, we use logarithmic differentiation. We use logarithmic differentiation. So this is first use. So given in terms of product, take log. That is generalization of product rule. Now consider problem number 2, A and B. So y equals to e to the power x sec x into log x whole divided by root over 1 minus 2x. And second one, y equals to x minus 1, x minus 2, x minus 3, x minus 4, x minus 5 total root. So if there are two functions in ratio form, we use division rule or quotient rule. Now here it is 4 functions. So it will be lengthy if we use quotient rule. But you know, log of a by b equals to log a minus log b. If it is given in ratio form, so log will be plus for numerator terms and minus for denominator terms. So we use this concept. So suppose problem number B, y equals to this. So take log on both sides. So log y equals to log of x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, and total power is half, root over half. So use property of log. So half come forward. So this is log x minus 1, x minus 2, and this one is x minus 3, x minus 4, x minus 5. Then use property of log. Log of numerator, so this is positive. Log x minus 2 is positive. And log of denominator is negative. Log x minus 3, log x minus 4, log x minus 5. So this is simplified form. So you can write log y equals to this, then you can write this step directly. Now this is simplified form. So next, differentiating both sides. These are all problem of board with respect to x. So log y, 1 by y, dy by dx. So this should be noted, 1 by y, dy dx. So half unchanged. 1 by x minus 1. Derivative of x minus 1 is 1. So this is 1 by x minus 2. This is minus 1 by x minus 3, x minus 4, x minus 5. Now what is dy dx? Y into, so y by 2 into 1 by x minus 1, 1 by x minus 2. So results are not in simplified form for logarithmic derivative. So this one. So you put value of y. So you get derivative. You must put value of y. So you complete the first one. So if it is given as a ratio of several functions, we use logarithmic differentiation. So use 2. Use 2. A function is given as a ratio of several functions. We use logarithmic derivative or differentiation. This should be noted. If it is given as a ratio of several functions, we use logarithmic differentiation. Next, third use. Now we consider the following functions: x to the power x, sin x to the power x, cos x to the power sin x, x to the power sin inverse x. Now y equals to x to the power x. Some student write this one, x into x to the power n minus 1. But this is wrong. Why? Because x to the power n, you can differentiate it by this rule. When n is constant, n equals to constant. But here x, this is not constant, so this is not true. So y equals to x to the power x. So dy by dx, x to the power x into log x. So y equals to, some student use this one, dy by dx, a to the power x into log a, base e. So this one is correct. Base is constant, then you can use. But here base is not constant, so you cannot use this one. So here power is constant, here base is constant. So this one is not correct. So look, here base is a function of x. Power is also function of x. Base, sin x, this is function of x. Function of x. So in this case, we take log on both sides. So what is log y? X into log x. X come forward. In this case, you have to take product rule. So differentiating both sides, WRTX. So 1 by y dy dx equals to x into log x. Derivative of log x is 1 by x. So log x unchanged, derivative of x is 1. So what is dy by dx? Y into 1 plus log x. So put value of x. So derivative of log x is x to the power x into 1 plus log x. So you are getting this result. Now You consider one more. Suppose cos x to the power sin x. This is fx of y. This is base. This is variable. So function of x, power is function of x. So you have to take log on both sides. So log y equals to sin log cos x, omitting one step. Sin x come forward. So 1 by y dy dx, differentiating both sides. If you take log on both sides, then you have to perform product rule. Log cos x unchanged. Derivative of sin x is cos x. Plus sin x unchanged. Derivative of log cos x. 1 by cos x into minus sin x. 1 by cos into derivative of cos x. So what is dy by dx? Y multiplied by cos x into log cos x. Obviously base is e, and this is minus tan x into sin x. Sin by cos tan x into sin x. So what is dy by dx? Cos x to the power sin x into cos x log cos x. So, and this is tan x into sin x. So derivative of logarithm. So it is not, result is not in simple form. So what is use 3? Use 3. Use 3. If fx equals to or y equals to fx to the power gx. Base is a function, power is also function. If y equals to fx to the power gx, we use logarithmic differentiation. So you complete the rest. So logarithmic differentiation. This has 3 uses. Today we are considering only the basic problems. So when number 1, when fx is given as a product of several functions, we use logarithmic differentiation. Case 1. Case 2, when fx is given as a ratio or division of several functions, we use logarithmic differentiation. And number 3, when y or y is given as fx to the power gx, base is a function, power is a function, we use logarithmic differentiation. So these are the 3 basic uses of logarithmic derivative. In the next class, I will solve some standard problem of derivative using logarithm. Thank you for today.